And we move on to the next presentation, and we have Hawre Jalal from the University of Ottawa, and he is going to be talking about Twig, computational efficient and fully vectorized approach to time-dependent Markov modeling in R. Hawre.
Great, thanks. Can you see my screen okay?
Yes, thank you.
Great, well, thanks everybody. I'll be presenting on Twig, which is a package that's been recently released. It's an update for a previous package called Gmod for grammar of modeling. I'd like to acknowledge my collaborators from Darth and also Jeremy and Tom, and the funding is from this work. The outline for today is to talk about the motivation for why do we need a grammar for modeling. And I'll talk about introducing the R package, Twig, and the online user interface, Decision Twig, using a time-dependent Markov model. And then, if time allows, I'll go a little bit into the inner working of Twig, how Twig works. So this was motivated by a movie, by a video that I saw on YouTube by Hadley Wickham on cupcakes. He was talking about the redundancy in cookbooks about cupcakes. So in his cookbook, there were recipes for different cupcakes. Like if you do a vanilla cupcake, you do mix, bake, frost, decorate, and you create a vanilla cupcake. And if you want to do a chocolate cupcake, then it's very, very similar, except for the main ingredient is different for the most part. And same for other cupcakes. So a big book was a lot of repetition, a lot of redundancies. So the thought is that you can summarize this into a single recipe, one recipe that's defined once, which you mix, bake, frost, and decorate. So if you change the main ingredients, whether it's vanilla, chocolate, lemon, you will apply the same recipe once, and then you will get the cupcake that you want. So that kind of struck me because in modeling, we do actually do very similar work. We copy and paste models by decisions, by states, and there's a lot of redundancy in our code. So that was the motivation for Twig. So instead of doing that, what Twig does is defines a single generic cycle tree. So this has been applied to all states, to all decisions, and all cycles, and all PSA simulations. And if something doesn't apply for that specific situation, you can just say the probability of that event happening is 0. So that summary of the generic cycle tree summarizes the components that we usually do by copying and pasting. So for example, here are like different decisions, decision A, decision B, and if the starting state is alive versus the starting state is sick, then you will have very, very similar looking events, but they are slightly different. So instead of representing this redundancy explicitly, you can define a generic cycle tree that gets applied to everything, to all the situations. And by that, you can summarize and you can reduce the redundancy and the complexity. And besides, it makes it a lot more transparent and easy to maintain in the analysis, just like the cupcake recipe. So I'll talk about a little bit on the Twig R package and also the Decision Twig user interface. That's both available online. So the Twig object is coded very similar to the grammar of modeling or the grammar of graphics, the ggplot and the tidyverse packages. So it defines is that you can have layers. You can have the decisions where the names are, your states. These are the Markov health states. For example, life and death, the initial probabilities, the maximum cycles, and then you have your events. And this could be multiple events, and I'll show you later. So for example, a death event could be either a yes or none, with a probability of die left over, and it transitions to what happens next, whether they go to the death state or they stay in their current state. And then you have the payoffs, which are cost and utility. Here's a snapshot for the Decision Twig, which is a bidirectional graphical user interface. You can paste the code here, or you can type it, and then you press on the generate Twig. It creates the graphic, or you can interactively build it by creating events by states, events, and outcomes, and then you press the generate code, and it will create the R code for you in here. So you can, so like if somebody is more visual, you can use the graphical user interface to kind of see what the model looks like and interact with it and being able to build the R code. And the components here in the decision twig of calls is these functions, this p die and the cost and the utility. These are functions that are defined just as the same as any other R functions. So p die, for example, is a function that says if a person is alive, then only p die applies for people who are alive. And if the decision is decision A, then you can reduce the mortality by 99% here. But if a person is already dead, then else is 0. So dead people don't die. So this is the probability for all else that applies for people in that state. And then you change the rate to a probability. The cost and utility, again, very simple ones. The cost function here is a function if only people are alive, the cost function applies to them. If their decision is A, then the cost of A. If it's B, then the cost of B. The utility is very similar. It depends on the state and the utility of a life, which is a parameter. If else the state is alive, then the utility of life otherwise is 0 for that. Now, the next thing you can define a probabilistic sensitivity analysis as a data frame for your parameters. The relative risk of mortality of A, normally distributed with this distribution, cost of A, cost of B, and utility of life. Again, very simple one just for illustration, but you can define that. You can also do a deterministic analysis by passing a list of discrete parameters. Now, you can run the twig by just passing the run twig function. You pass in the object, the twig object, the myTwig, the parameters, the PSA parameters, and you define the number of cycles, which are here 50 parameters. Then you can look at the outputs of that. These are the main outputs, but there are also a lot of intermediate outputs about the inner calculations, about the distribution of cost and utility per cycle, per PSA, and all the detailed outputs are also retrievable. You can receive them back. And you can also do the calculate ICERs. This is from the DEMPAC package. You can get the results, the mean EV, and it does the ICER for you. You can also produce the graphics. So here's the SIAG. You just pass in the simulation. This is the detailed PSA level results. You can pass that, and you define the willingness to pay range, and it will produce the SIAC curve for you. Now, the more advanced Markov model, this is the tutorial is available on GitHub. If you go to articles and the Markov time dependent, there's a tutorial. It's a more involved analysis that shows a lot of the features of time dependency, which are either age time dependency or time in the state, or sometimes we call it tunnel state time dependency. And there are things like transition rewards and also event dependency. So for example, what happens if there's an event, but there's a prior event happening? Conditional dependency of those events are also illustrated here. So there's the twig for that one. There's multiple events here, and then there are also multiple transitions. So you can have multiple outcomes here, and then there's the graphical user interface for it. Again, you can paste the code here and then generate the twig or go the other way around. So this tutorial to introduce is so this tutorial illustrates the dependence on decision and state, the cycle. This is the age dependency. Cycle and state, this is the parameter for tunnels. So if a person is in cycle and state 1, that means they have spent in the state 1 year or 1 cycle. If it's 2, it means 2 cycles or 2 years, or called like state residency or a tunnel state. Or you can have a dependence on prior events, transition rewards by referencing event outcomes in the twig. For example, if a prior event is equal yes, then do something new or apply a new cause or new transition and so forth. So you have access to all the inputs of the parameter and the structure of the model. So you can have multiple sequential events, as I showed, and also reward discounting. This is a discount rate that we usually apply for cost effectiveness analysis. And here's just for comparison, this is the Twig code on the left side, which is 167 lines, and the standard R code that we published with the paper, which is 683 lines. So there are a lot of the things here are redundant because we are using base R for the analysis, but there's a lot of copy and paste. And as even if you can't read this, but you can see the different like the patterns of the code. You can see there's a lot of copying and pasting here, which makes it maintenance and debugging complicated because every time you change something, you have to change a lot of the details, a lot of the copies of your code everywhere else, and that makes it cumbersome sometimes. So the goal of Twig is to represent every object, every component of the model only once. And if you see here, like the part I outline here in orange is the probabilistic sensitivity analysis parameters. A big chunk of this code is actually the PSA distributions, which cannot be reduced any further. And the inner working of the Twig is that we evaluate the model once and for every combination of input. So this makes the analysis very efficient. So the idea is that you define your event probabilities. These are the things that determines the transition from one state to another through the different events, and the payoffs. These are the cost and the utilities, which could be a function of each one of them could be a function of the decision, the state, the cycle and state, the prior events, and the model parameters. And then once you have these, you evaluate these functions for their input parameters, the exhaustive combination of all the permutations of their input parameters. And these are, for example, given by the decision 1, 2, and decision D, S, the states, state 1 to S, the cycle and state, and the event. Not all functions use these. So what's been done here is that if a function, for example, only use D, decisions and state, it only gets evaluated for those two, the permutation of those two parameters. And then they evaluate it, and the results of that function is stored. So once this has been stored, then it's being broadcast and forecasted without recalculations. So everything is being calculated only once, and then is being projected to the maximum combinatorials of the functions. For example, if a model is cycle dependent, then all the other functions are the arrays that being the multi-distributional array, the multi-dimensional arrays are being forecasted to the additional dimensions that are being used, so that then the calculations are done. So what happens then is that within cycle event paths are being calculated. So different paths from one state to another are being calculated, and these paths are being combined. Then once they've been aggregated, transition probabilities are computed per state and cycle, and this being changed to a transition matrix. This transition matrix then produces a cohort trace for the model, and then cost and qualities are being calculated in the model. So these are like the background, which makes the computation very efficient because there's no reevaluation of the functions. The functions are only stored in very compact arrays, and those arrays are being broadcasted later for additional dimensions as needed. And just to summarize, standard Markov models are efficient, but they are often repetitive. And the complexity with that is that because we depend on states, then we get to the habit of reproducing the model or copying and pasting the code for each state so that we distinguish the different outcomes for different initial states. The Twig uses a grammar of modeling, defining decision states and events and transition mapping and payoff only once. And a single generic cycle tree is applied repetitively across decisions, states, cycles, and simulations. So everything is being, all the other probabilities and payoffs are written as functions. So you only have one place that you have all your cost calculations being done, for example, or all of your quality of life. The utility calculations are being done only once and being calculated. And then Twig reduces this redundancy and improves transparency by producing intermediate outputs, such as function evaluations, transition probabilities, Markov traces, and cycle rewards. So you can also look into what are the outputs of the functions, so you can double check if the functions that you coded are actually producing the outputs that you expect from the outputs, and also the other intermediate outputs, for example, Markov traces, cycle rewards, and so forth. So to conclude, I have some resources here. So tutorial on Decision Twig is available on this link on Decision Twig. Tutorial on Easy Twig on GitHub is available on the Twig under the articles tab. And Twig help files are also are very helpful for giving you details about the different outputs that have been produced. Both Decision Twig and Twig support decision trees. I only talked about Markov models, but you can also do decision trees. For example, there's a tutorial on herpes virus encephalopathy on GitHub as well, under articles. And there are also the Dart resources that we have that are generally useful for doing Markov models and so forth. So thank you very much. This is all what I have for the slides.
Brilliant, Hawre. Thanks very much for that written presentation. I haven't tested Twig yet, but I'm looking forward to. There are a couple of questions in the chat, and one is from Javier. He asks, how would you compare this package to other alternatives like HESM, and what would make a user choose one over the other?
Yeah, like there are definitely a lot of exciting changes happening in the field. Lots of different packages are producing, which is I think it fulfills the demand and the interest in using R. I haven't compared this package to other packages. This was just an idea, something that was bothering me quite a bit about the redundancy when I was building models, about the copy and paste and trying to maintain every change every time. So I had this idea, and then when I saw that video by Hadley Wickham, then that kind of was the trigger for me to pursue this package. But this is a very exciting time, I think, that the field is changing to a more open source and more R, and hopefully more transparency in the field.
Okay, thank you. And Howard, as also sort of a lead question from Javier, does Twig allow dependence on time in model, i.e. still Markov but time inhomogeneous, or through tunnel states allow dependency on time in state, i.e. semi-Markov model as in HESM?
Yeah, so there is a dependency. You can create additional. So what happens in the background? It creates additional states. So if you define a tunnel state, for example, like a 10 dependency on 10 cycles in the state, then what happens in the background? It expands that state into 10 additional states, and it tracks time in there as a tunnel state. Yeah, absolutely. This can be done with the cycle and state. And that's been illustrated in the tutorial as well. If you look at the tutorial, there is a section on how to do a state residency. That's what we call it in using Twig. And the details about how to do that in base R as well is also available in the tutorial and the paper that I was referencing.
Okay, great. So we need to look into that tutorial to have more details on it. And Darren, we have a question. You've raised your hand.
Hi. Hello. Is this appropriate for... Hello, can you hear me?
Yes,
Yep.
Yes.
Is this appropriate for sequence modeling where patients can jump from any point in any tunnel to any other tunnel at any sojourn time for any number of tunnels? Or should a specialist tool be used when a specialist job is needed?
So usually in Markov models, like a person when they jump from a tunnel, they start from that tunnel, so that we can keep track of their starting time, and that's how I've been coding it. But if there's a interest in like jumping tunnels, for example, if there's a relationship between different starting times, like if states are parallel, so you can go 3 states in one state, and then you want to keep track of them later on, you can create additional states, or you can create properties for that state to be able to keep track of them. And like you can define a more complicated tunnel state at this state. But yeah, I'll be interested in learning more about that, about jumping tunnels and distributions to to go from one tunnel to another.
Yep, I presented on a package for it yesterday.
Nice.
So you can just have a look at the slides.
Well, I'll definitely look it up. Thank you.
Yeah, thanks.